Hello friends and welcome back to your channel GATEquestionsECE, and I am back with next question in this series of random variable, and the question code is 113. If n number of independent and identically distributed i.i.d. continuous random variables x1, x2, x3 up to xn are related to random variable z by z is equal to minimum x1, x2, x3 up to xn, then which of the following statement is true for the PDF of Z? So let's see how to solve this question. Before going to the solution of this problem, let's see in general what will be the CDF of Z, where Z is minimum among the n random variables. So if Z is equal to minimum among n random variables x1, x2 up to xn, where x1, x2, x3 up to xn they can be discrete random variables or can be continuous random variables, and also they can be dependent or independent. Any of the case is possible. So in this case, we know if we have two random variables x1, x2, then for z is equal to minimum x1, x2, we have solved in previous problem that its CDF will be given by sum of marginal CDFs of x1 plus x2 minus the joint CDF of x1, x2 up to sample value z, z. So that is the result for two random variables. Similarly, for three random variables x1, x2, x3, where z is minimum among these three random variables x1, x2, x3, then the CDF of z will be sum of the marginal CDFs of x1, x2 and x3 minus the joint CDF of x1, x2 sample value z, z minus the joint CDF of x2, x3 sample value z, z minus the joint CDF of last possible combination is x3, x1 sample value z, z minus the joint CDF of all three random variables x1, x3, x2, x3 sample value z, z, z. Now if you observe, these are 2C1. These are 2C1 combinations. Out of 2, when we choose 1, so these are 2C1 possible combinations. And this is out of 2, we are choosing 2. So these are 2C2, which means 1. Because 2C2 will be equal to 1. So this is 2C2 combinations. Similarly, if we observe here, out of 3, here we are choosing 1. So these are 3C1 combinations. Similarly, you can observe that when we choose 2 random variables out of 3 random variables, there are 3 possible CDFs. So these are 3C2 combinations possible for choosing 2 out of 3 random variables. Similarly, the last case, these are 3C3. So out of 3, we are choosing 3 random variables. So only one CDF possible is this CDF. Similarly, we can generalize and get the result for this case for n random variables. So let's write for n random variables. For n random variables, we can write that the CDF of z will be equal to f of x1. I am not writing here bracket and z with this expressions. So next term will be f of x2, f of x3 plus up to f of xn. So these are for n random variables. Out of n random variables, we are choosing 1. So these are NC1 possible CDFs. Here it is plus. So next term will be minus sum of all possible combinations of joint CDF of two random variables. There will be NC2 possible combinations of such CDFs. Mathematically, we can write these as f of x1, x2 plus f of x1, x3 plus so on, all the possible combination of x1 with all other random variables, then plus f of x2 and then x3 plus all the possible combinations of x2 with all other random variables, and so on. We can obtain all the possible combinations of CDFs for two random variables, and you will find out that there will be NC2 such possible CDFs plus same term sum of all the possible combination of joint CDFs for three random variables. So there will be NC3 such possible CDFs. Note here, we will be using alternate plus minus signs. Here it is minus, next term is plus. So next term will be minus sum of all joint CDFs of four random variables. So for four random variables, all possible CDFs we will have to sum up. So there will be NC4 such possible CDFs, and so on up to last term. We can go on doing this and up to last term, which will be the joint CDF of all n random variables. So joint CDF of all n random variables will be z comma z comma z up to z. So this is n times we have to write z. Also observe here that the sign of last term here can be plus or minus depending upon the value of n. So to include this, we will modify this last term. So here it will be plus minus 1 raised to power n minus 1. You can see here quickly that for n is equal to 2, this case for n is equal to 2, when there are two random variables, here last term has negative sign. If you put here n equal to 2, you can observe it will be minus. Similarly, for this case, for three random variables, you can observe here that last term has sign plus. So if you put here 3, so 3 minus 1 will be 2. So again it will be plus. So this is the CDF of Z in the most general case, where all the random variables can be either discrete or continuous random variables, or they can be dependent random variables. So now next case, in our question it is asked about the independent and identically distributed random variables. So let's see what will be the CDF of Z in case of independent and identically distributed random variables x1, x2 up to xn. So if x1, x2, x3 up to xn all are identically distributed as well as independent, i.i.d, independent and identically distributed random variables, then we know that all will have same CDF. So marginal CDF of all these random variables will be equal. Similarly, because they are independent, we can write that joint CDFs xi and xk, where I and k can take values from 1 to n, we can write it will be equal to the product of marginal CDFs. Similarly, we can do this for three random variables, the joint CDF of three random variables xi, xj, xk. So it will be equal to the product of marginal CDF of. Similarly, we can write this for the joint CDF of four or more number of random variables. So writing this up to n random variables. So last term will be product of all random variables x3 up to xn. So that will be equal to marginal CDFs of x1, marginal CDF of x2, marginal CDF of x3 up to f of x of n. So product of marginal CDF of each random variable. You can observe here that all these conditions are because of the mutual independence of random variables. So these are due to mutual independence of all n random variables. And this first condition is due to identical distribution. Identical distribution of all these random variables. So combining all these conditions and putting all these conditions in the previous result we obtained, we can observe here that these, instead of all these marginal CDFs, we can write f of x of 1 for each of these terms. And since there are nc1 terms, so after summing up we will get nc1 times f of x1. Similarly, we can observe that each term in this summation will be f of x1 square, and there are nc2 such terms. So summation of all these terms will be nc2 times f of x of 1 square. Similarly, we can do for all other terms. So if all n random variables are independent and identically distributed, then the CDF of z will be equal to nc1 times f of x of 1 of z minus nc2 times f of x of 1 of z raised to power 2 plus nc3 f of x of 1 of z raised to power 3 minus nc4 f of x of 1 raised to power 4 plus so on up to last term, which we will write minus 1 raised to power n minus 1 nc n f of x of 1 of z raised to power n. So this is the final result for the CDF of z, where z is equal to minimum of all these n random variables, and all of these are independent and identically distributed. Also note that this formula for the CDF of z is valid for both continuous and discrete type random variables. Now let's calculate the PDF for the case when all these n random variables are continuous random variables. So considering this is the CDF for continuous random variable, let's calculate the PDF. So differentiating both sides by z, we can easily get the PDF of z. So differentiating both sides by z, we get so the differentiation of CDF of z will be the PDF of z. Similarly, on this side we differentiate with respect to z. So the first term will be nc1, this is a constant, and differentiation of this. This is the CDF of x1. So differentiation of CDF of x1 will be the PDF of x1. So we can write small f x1 of z minus nc2 is again constant, and differentiation of this will be, so 2 times f of x of 1 z, again differentiation of this, which will be the PDF of x1. So next term will be nc3, differentiation of this will be 3 times f of x1 z square, and again differentiation of CDF of x1, which will be the PDF of x1. Similarly, for all other terms, you can do plus, last term will be minus 1 raised to power n minus 1. This will be, see, ncn is 1, its value is 1. So we can write here 1 into differentiation of this term. The differentiation of this term will be n times f of x1 z into power n minus 1 into differentiation of CDF of x1, which will be the PDF of x1. So this we can write f of z. For the simplicity of writing, I will not be writing this bracket and z sign in all these. So we can write it as f of z is equal to nc1 is, its value is n, and this we can write f of x of 1 minus nc2 will be equal to n into n minus 1 divided by 2 factorial. So 2 factorial is 2 into 2 times f of x of 1 into small f of x of 1. Next term will be nc3. So nc3 is n into n minus 1 into n minus 2 divided by 3 factorial. So 3 factorial is 6 into 3 f of x of 1 square into small f of x of 1, and so on up to last term, which we can write plus minus 1 raised to power n minus 1 n into f of x of 1 raised to power n minus 1 into f of x of 1. So you can observe here n into f of x of 1 is common in each of these terms. So taking this common term out, we can write f of z will be equal to n times f of x is common. So remaining will be, first term will be 1. Next term will be minus, so n f of x of 1 is common, remaining term will be, this 2 will cancel out, left out term will be n minus 1 into f of x of 1. So n minus 1 f of x of 1 plus next term will be, so this will cancel out, this n and f of x of 1 will be common, and remaining will be n minus 1 into n minus 2 into f of x1 square. So n minus 1 n minus 2 divided by 2 into f of x of 1 square, so on up to last term, which will be plus minus 1 raised to power n minus 1 into only fx1 raised to power n minus 1 will be left. So f of x1 raised to power n minus 1. If you note here, this one we can write n minus 1 c 0, and this n minus 1 we can write it as n minus 1 c 1, and this term we can write it as n minus 1 c 2. In this last term we can write here 1. This 1 we can write as n minus 1 c n minus 1 because its value is 1. Here it is f of x of 1. So f of z will be equal to n times f of x of 1 into n minus 1 c0 minus n minus 1 c1 f of x of 1 plus n minus 1 c2 f of x of 1 square minus so on up to last term plus minus 1 raised to power n minus 1 n minus 1 c n minus 1 f of x of 1 raised to power n minus 1. If you observe carefully, this whole term in the square brackets is nothing but the binomial expansion of 1 minus f of x of 1 raised to power n minus 1. So we can write that the PDF of z will be equal to n times f of x of 1 n times the PDF of x1 into 1 minus CDF of x of 1. Here I am writing small z raised to power n minus 1. So this is the end result. This is the PDF of z for the case z is equal to minimum among n random variables x1, x2, x3 up to xn, where all these random variables are continuous random variables and they are independent and identically distributed. So we will use this formula in case of i.i.d and continuous random variables. So the correct answer is option 3. Also, just for the sake of comparison, I will like to write here what will be the expression for the PDF of z if z is maximum among all these n random variables, where all are continuous random variables and independent and identically distributed. For that case, the PDF of z will be equal to n times f of x of 1 into f of x of 1 z raised to power n minus 1. You can compare here expressions for the PDF of z for the minimum and the maximum case, and you will find out that n times f of x of 1 is present in both the expressions, and also this power is n minus 1 in both the expressions. The only difference is here it is 1 minus CDF of x1 and here it is CDF of x1. So you can memorize these two formulas as they will be very helpful in solving numericals based on continuous random variables and independent and identical distribution for the case of minimum and maximum functions. So I hope you are learning from my videos and I will be bringing more such videos. So keep supporting and please do press that like button below this video and subscribe to my channel. So thank you for watching this video.